Hi everyone, this is JP from CRC. Uh, Today we're going to do a tutorial about EasyC version 4. Uh, Actually, the first part of the tutorial will be very simple. Uh, EasyC is a program that allows you to switch the default program from your robot in order to make it do whatever you want, depending on which channel you want to control which motor. So basically, once you've installed EasyC, there's a possibility that the driver for downloading the program into the Cortex uh, has glitched and did not install well. Uh, to ensure that the good driver is installed, you have to go to Control Panel, then you go to System, then you go to Device Manager, Ports, and here, if it's written USB serial port, then well, it's not good. It's not the right driver. So you double click, you go in driver, update driver, and you go to browse my computer for driver software. Let me pick, and then you have the choice VEX Robotics COM port. Note that this glitch only happens when you plug directly into the joystick, the VEXNet joystick. It does not happen when you plug directly into the Cortex. So basically we're going to use a lot of the wireless capabilities for programming, either for remote downloading or remote debugging. So I strongly suggest that you verify if this is okay. So you only have to do next, and then it will work. So once you've made sure that your driver is the right one, and you open the program, here's what you get. This window, you can do File, New Standalone Project. While it's true that we are doing a competition, actually we're not using all the components required in the official VEX competition, which means that we don't necessarily have to do a competition project. So we're going to do a standalone project and then enable Wi-Fi capabilities because, well, whether if you want an autonomous robot for the programming competition or just the, the regular drive with the joystick, in either way, for the CRC, you'll need to have the joystick to enable your robot, whether it's for just pressing a button to start the program or driving it with the whole joystick. So once you're in there, what you get is first of all the menus on the top. On the left, the function blocks, which is every single function that EasyC can do for you. It seems like a lot, but we'll sample that out later on. You get the main working window, and if you do window block and C programming, you'll see that just besides, if you want to learn the whole C language syntax, it can translate what you're doing from EasyC to what you can get here in C language, which is pretty useful. And next, Project Explorer gives you shortcuts if you're ever deep into your program and you want to do control configuration. You double click and it opens the window. It's pretty useful. Use the output and task window. It's well, it's after you downloaded your program. We'll check that out later. So first of all, when you start doing your robot, what you want to do is configure the Cortex. When you configure the Cortex, actually what you can do is you can give a description to each and every one of the ports. It seems quite unuseful, but actually it is very useful because here, let's say that this motor, motor number 2, is the left wheel. from the back. Well, each and every time I'm gonna need to use the left wheel, the back left wheel actually. Um, when I'm going to choose my port, EasyC is gonna tell me, oh, this left wheel in the back, it's port number 2. So it's quite useful, especially when you have 10 motors and lots of sensors. It's gonna be very useful. Other thing you can do in this window is change digital and inputs and outputs, because actually this is an input, this is an output. You'll see that the arrow is pointing outside for the input and inside for the input. When you click it, it changes. We will get to that when we will use more sensors, but it's quite useful to be able to change everything. So another thing you can do, and that's what I'm going to do right now, is to import the configuration from another project, because my project, my robot for tutorials, has lots of sensors, and I don't have the time. Well, actually, I would waste your time just configuring the whole thing. So when you do project import controller configuration, it looks every single project you have, which means it can be quite a lot. If you want to narrow your search, you can just, for example, search here if you know the project name, or even you can browse more specifically. Mine is called Tuto, so well, actually it's right here, so I won't narrow down the search, but you can do it. Then you click import, yes, and once that's done, double click config, and everything for my robot is here. So yeah, that's the config window for you. Another window that is very, very useful when you're programming is the online window. Here's what it looks like. Basically, when you open it, you have an enable option. You click it, and then it enables you to control the robot via this window instead of the controller. So basically what you have is all the motors here, the integrated motor encoders, digital in and out, analog, battery voltage, and here is actually it's a rundown from the configuration. Here the config. Basically what I've done, well, actually the first thing I suggest you do is to try each and every motor, because here you won't know what I've written here. Plus avant means the positive goes forward. You won't know that until you try it. And the way to try it is to take the cursor here, just scroll it that way. And when I do that, well, actually when I did that, I saw that when I go here in the positive values, the motor goes forward. So basically I just added on here that positive goes forward. Well, yeah, there. And I did it for each and every motor. Here I said the pince fermée, meaning the claw, when it's positive it closes, because in the context it has way more sense. Your bras plus monté means the arm, when it's positive it goes up, which also in the context has more sense. Here it's all my sensors, and here the analog sensors. So basically what you can do with the online window, once you've tried everything, you can group the motors. For example, I can have motors from the drive, motor 1, 2, 7, and 8 grouped all together. And then I know this one goes forward, this one goes backwards, so I'm gonna invert this one. This one goes forward, this one goes backwards. And when I move one cursor, every motor will move. So basically, when I did that, my robot just started going forward, and then I put the cursor backwards, so it went backwards and etc. So that allows you to verify what you've done here in case you've made a mistake or whatever. Uh, it's gonna be useful. So that's for the motors. When you get to the digital inputs and outputs, here you can see, well, the encoders are plugged here and here. Uh, you can basically test them when you're turning the wheels. It should go from 0 to 1 to 0 to 1. But what's really interesting here is how to test the limit switches. Limit switches, they're switches that you put to limit, let's say, an arm's movement. Uh, that's very useful because sometimes in the competition, even if there's a driver, the driver doesn't necessarily have a good angle to see if, well, let's say the arm is fully upwards or fully downwards. Uh, and sometimes you can make the robot do some stuff that it doesn't want to do and just simply break it. So this is a security switches. So you can test the switches. Here they're plugged in 5 and 6. When you press it, it goes to 0. So here I checked that my two limit switches were working, and the analog inputs are very useful because actually here are 3 line trackers in the 6, 7, and 8, and you can define what's white, what's black, and etc. So yeah, that's pretty much it. There's the battery voltage to check up on your robot if the battery is okay, if you need to change it. That's actually quite useful, especially during the competition. And yeah, that's all for the online window. So basically, yes. So basically, you can get it either from here or there. And when I said you just have to click enable, you click on enable, and that's it. Okay, so now we've talked way more than enough about EasyC itself. Let's get down to the meat and bones. Here's how to program something that's remote controlled with EasyC. So basically what we're going to need is 2 of these folders. Actually, this one we're only going to use one thing, and the rest is going to be in the joystick one. So how it works is basically that you can take any of these items, click it and drag it, and then something pops up. What we're going to need here is exactly a while loop, and basically what's in parentheses is the condition for the while loop to do what's in the brackets. Actually here I already had a while loop, so I'm going to delete it. And basically now the program, instead of just reading from top to bottom, so reading the config, globals, begin, variables, and then doing the program once and ending, the robot will be stuck inside the while loop, because here it says 1 equals to 1. In programming, having 2 equal signs means a mathematical equation, and this means that you're giving, normally it's a variable, you're giving the variable, you're assigning a value to the variable. But here's not the place to do it, and actually we're going to talk about that later in an autonomous tutorial, but for the moment let's just say that while 1 equals 1. Then you may be wondering, why would we have to put 1 equals 1? Well, that's exactly what we need, because 1 is always equal to 1. So seeing that, the robot will be stuck forever doing this until it runs out of battery actually. So basically while 1 equals 1 can be shorted because EasyC allows it. So if you're lazy, you just put while 1, and then well, the robot will be stuck doing these actions. So you put everything you need inside the while loop. Some things will go before the while loop, but usually it's just starting sensors, so we'll discuss that in an autonomous tutorial. So basically, what's left to do is just to assign each motor to a button on the controller. And to do that, we have every single one of these functions. First function is the arcade function. My robot has 4 drive motors, so I'm going to use the 4 motor ones, but if you only have 2 motors on your drive, you can do the 2 motor option. So basically you just drag it and drop it inside the infinite loop, and then this window appears. So inside this window you choose joystick number 1 because you only use one controller and it's labeled as number 1. Transmitter channel. When you have the controller, you can see that on the controller it's written numbers. For example, here it's 1, 2, 3, 4, 8, and 7. That's the channel number for each channel. For example, this joystick, when you go up and down, it's channel 2. When you go left to right, it's channel 1. These buttons, they're channel 6. So there's U for up, D for down, L for left, and R for right. That's channel 8. On the shoulders here, you have channel 6 and channel 5. You cannot see them in the picture, but they are there. Channel number 7 is here, number 3, and number 4. So basically, here, if you want to assign, well, by default, forward is the right joystick, and the rotate is also on the right joystick. But if you want to use the left joystick, then you can look at the controller and just tell, okay, well, forward is channel 3 and rotation is channel 4, and that's it. And then you can control via the left joystick instead of the right one. Then you're going to assign your motors. So left front motor, here is FL for front left. Plus arrière means that the positive will go backwards, so I have to invert its direction. So I put 1 to invert direction. Left rear motor, back left here. Plus arrière means again that I have to invert the direction. Right front motor, front right, plus avant means that I don't have to. And finally this one, right rear, so back right plus avant means we're okay. So you just press OK, and well, when you download this, doing build and download, afterwards you can control via the left joystick your robot. It will drive forward, backwards, etc. So here's an example. Okay, so if ever the arcade drive is not suited for you, you can also choose another style, the tank drive. The tank is quite easy to understand. We'll see that in a moment. We'll see an example. But first we have to configure it. So joystick 1 again. It's always going to be 1 because we only have one joystick for each robot. Here, left channel is basically the left joystick, and right channel is basically the right joystick. So channel 3 and channel 2. Afterwards, you configure the motors. So left front is front left. You have to invert. Left rear is back left. You have to invert. Front right. Here you don't have to invert. And back right, we don't have to invert. You press OK, and then how you control the robot has changed from one joystick to two joysticks. And an example. If you have special wheels, like I do on this robot, you can also try the holonomic option. This option actually is quite useful in some games. Actually, last year it was very useful. 2 of the 4 robots in the finals were using that kind of propulsion. So yeah, it was pretty useful. What it allows you to do is to go forward, backwards, left and right like a crab, and rotate like a usual robot will do. So actually I prefer having my forward reverse on channel 2, so I'm gonna put channel 2 here, and then I just have to configure my motor. So left front left here, I have to invert. Left right, excuse me, left rear is back left, I have to invert. Front right, I'm okay for inversion, and there you go. So once this is configured, this is actually very hard to program without this function, but with this function it's a breeze. You can look at an example of what's an holonomic drive. Okay, so once that is done, we've taken care of the drive of the robot, but we'll need more than a drive to play any game. What we're going to use is these functions. Basically, joystick to motor is an easy function to understand. You just take a channel on one of the joystick of the controller, and you assign it to a motor. So basically, I've used channels 1, 2, and 4, so I'll take channel 3, which is the left joystick for up and down, and I'll use this joystick to go up and down with the arm of my robot. So here, bras plus monté means the arm on the positive side, it goes up, so here I don't have to invert the direction because, well, I want when I put the joystick up that it goes up. Otherwise I just invert the direction, but it's already done like that. Put OK, and that's fine. So that's gonna control my arm. But here's the deal. On my arm, I've put 2 security systems named limit switches. These switches, when they're triggered, they'll stop the motion of the arm, even though I'm sending the message to the arm, oh, go down, go down. If the down switch is pressed, it won't go down. That allows me to actually during the competition not break my arm because I don't see what I'm doing and I just go downwards and downwards and downwards, and then the motor just bends my arm or breaks it or something. So that's quite a pretty useful system. If you want my advice, use them. You never know when they're useful, and they're always pretty useful. So basically I'm going to take channel 3 again. Bras positive égale montée. So that's the same thing as always. I'm not inverting the direction. Positive limit switch means when I go up, I'm using the limit up switch, and when I go down, I'm gonna be using my limit down switch. As you can see, configuring and naming each and every port is very useful when you're programming. Otherwise, you'd have to figure it out again and again and go for trial and error. So I strongly suggest that you config at the beginning, and there you go. So when I go up, when I put my joystick up, the arm will go up until it hits the switch, and when I go down, it will go down until it hits the switch, and it won't go down any further, even if I tell it to go down. So that's the limit switch. Here's an example. So now we've done the arm. The only thing left to do is the claw. The claw, actually, we don't have any more joysticks left, so we're going to use buttons. And buttons are digital, digital signals instead of analog. Analog means you've got from minus 127 to plus 127, while digital is just 0 or 1. So here we're going to use the digital joystick digital to motor function, which is a little bit different, but nevertheless it's quite useful. Here I'm gonna want to use the channel 7 because I think it's ergonomically the best choice. So left I wanted to open the claw, and right I wanted to close the claw. So here, forward direction, I'm gonna say 4, because if I remember correctly, here the motor pace plus is close. So to close my claw is the positive direction. Here I'm selecting the right button and then the value assigned to it. Here, since it's a claw, it's kind of a fragile and precise mechanism. I'm not gonna put full throttle here. 127 is full throttle forward. I'm gonna slow it down a little bit. I'm gonna put 90, and you can try different values and calibrate it so that the claw is optimal, so it has a good grip, but it doesn't go too fast. You can calibrate it on your own. And to open the claw, I said I wanted the left button to do it, so button 3, and here I'm gonna put minus 90 because I don't want my claw to open very fast. I just want it to open at the same rate as it closes. So you just press OK, and then you have it. Your claw is now fully functional. So next up is joystick to digital output. That's useful for pistons and servo relays. Pistons are used with the VEX pneumatics kit, and servo relays can control the power motors well, actually they're not as useful as the Talon, which has a graduated signal. It's just on off, so it's useful, but let's just say that you cannot use it for anything. You cannot drive very efficiently when it's just on-off signals, but basically the principle here is the same. So you take, let's say, channel 8 button, any button, and then choose the output. Here I don't have any configured on my tutorial robot, so I won't show you, but it's quite easy to do. And latch is actually it's the same principle, but here you assign the channel to one specific button. So let's say you have a piston. If you press it once, it will deploy the piston, and if you press it another time, it will retract the piston, which is quite useful. And afterwards, these ones I'll talk about it in more tutorials, but we have the last very useful one, the joystick analog deadband. This one is actually quite useful. So basically you choose joystick 1, analog channel 1, for example this joystick, and what it does, a deadband is actually a cutoff where because of the construction of the controller, the joystick they don't necessarily come back to the 0 position when you let them go. Sometimes they'll come back to 1, 2, -1, -2, 4, maybe even more if the controller gets old or damaged. But here, to counter that, the program can give you something that's called a deadband. So basically here, if I choose a wider deadband, let's say from 8 to -8, it means that if I release my joystick and it doesn't come back to 0, but for example to 7, which is between -8 and +8, then the cortex will send no signal to the motor. Actually, it will send a stop signal, which is the 0 signal. So basically, it's going to replace every single time you're giving the -8 to +8 signal to your robot. Every time you're going to send it, then it will not send -8 or -7 or -2 or 0 or 7 or 8. It's going to send 0. So that's useful, especially for the drive, because, well, you don't want your drive to be too nervous, or when you're trying to be static and just release the joystick, then your robot goes forward. That's not very useful. So you'll want to put a deadband, so you just have to put this one. You can try different values to see which values fit the most for your robot. Then you press OK, and then you're good to go. So basically here I need more than just one deadband, because I've got 4 channels on my joystick, so when I can add more, and then I'll be ready to build and download the project. Click it and it downloads. Note that actually I can try it. Press yes. Here you get the status of your batteries, which is very useful because you'll know when to change them. Here's the progression of your download, and afterwards, when it's downloaded, then your robot is good to go. There you go. So actually, right beside me, my robot is starting to do some small noises of I want to move, and yeah, so everything's downloaded, and if ever anything goes wrong, if you get into trouble and want to revert back to the default code, you just have to click either on this one or this one. This one is the factory default, this one is the EasyC default. Both of them are very similar, so you just click, press yes, and then it gets back to factory default, and well, what you supposedly broke is unbroken. So there you go. If ever you have any questions, feel free to contact us on our website, www.robo-crc.ca. And yeah, just go ahead and post a question. It's quite easy to do, quite fast, and it will be a pleasure to answer you. So good luck.